In this video, we are going to be looking at the model of the atom and the different parts of the model, along with how we got to this version of the model from some of our earlier versions through an experiment called the gold foil experiment. As I take notes on the screen, make sure you're completing your notes on your handout and adding any notes that you'd like on the side. So one of our first models of the atom is on the before side. We call this the plum pudding model or the chocolate chip cookie because it does look like a chocolate chip cookie. It's just a mass that we know is positively charged. And then within that positively charged mass, we have some negatively charged particles, which we call electrons. Now, that looks very different from our current version of the atom, which you see on the right, where you have the positive particles along with something else that's not labeled in the center, and electrons are only on the outside. So how did we get from the before to now? Well, that was through an experiment called the gold foil experiment conducted by Rutherford, who you see with a wonderful mustache on the left. It is where we shot alpha particles or positive particles at a piece of gold foil, and those particles went into a whole bunch of different directions. And you're like, how does the alpha particles being shot at foil tell us what the atom looks like? Well, a lot of the alpha particles went in different directions, and those directions tell us what atoms are made up of. So the first one, which is actually what most alpha particles did, is they just went straight through. So all of these black arrows you see in this picture just went straight through the gold foil, which means that most of the atom is actually empty space. If it were to hit something, it couldn't just go straight through. So that was finding number one. Finding number two, from this arrow with the 2 labeled on it, it had a small deflection. So it hit the center, or it hit something and went off on an angle. And so what that told us is, in this mostly empty space, there's actually a small, very dense core, which we call the nucleus, that has all of the mass. And then the third thing that we found when the alpha particles were shot at the center was that there was actually a large deflection, meaning it hit the center and almost came right back at where they were coming from. And what that told us is that the center is positively charged. So how do we know it's positively charged if it's coming right back to us? That's because if you think of a magnet, opposites attract and they connect. And similar charges actually repel and push apart. So when these positive alpha particles went to the center, because they had similar charges, they were actually repelled back to where they came from. So that's how we know that the center, the nucleus, is actually positive. So here we have all the different parts of the atom. We're going to go through and label each part. As I complete the chart, make sure you're doing it on your paper. So first up, we have the protons. Your protons are your positively charged particles. Hi, you coming up? Hold on, the cat wants to be involved. Come on. Come on. Really? She got tired jumping. I hope you heard her. Anyway, so the protons are positive. They are located in the nucleus, which is the center of the atom. As you will see, they have a plus sign on them, which means they have a positive charge. So each proton has a positive 1 charge. And then the relative mass is 1. So the mass of all these particles are actually so small, a whole bunch of decimal places. But when we compare them to each other, we just use numbers like 1 and 0 instead of writing all of those decimals out. The next particle we're going to look at is the neutrons. Nope, that's not the right color. Neutrons are also in the nucleus. As you can see, oh, there she is. I don't know if you can see her. You want to say hi? Say hi, everybody. That's Lucille. The neutrons are also in the nucleus, and as you can see, they don't have anything written on them, which means they don't have a positive or negative charge. They actually have a neutral charge, which, what the heck? We'll just erase this part. They actually have a neutral charge, which means that they have a charge of 0, and they also have a relative mass of 1. And then our last particle we're going to look at is the electrons. The electrons are these green ones on the outside, and they are actually in a place called the electron cloud. Sometimes we will refer to them as orbitals, like the circles or rings around the nucleus. We'll call them orbitals. As you can see on the picture, they have a negative charge, and each electron has a -1 charge. And we know the atom is mostly empty space, so that means their mass is much smaller than the protons and neutrons. So we represent that mass as a mass of 0. So if you didn't complete this chart, make sure you pause the video now to fill it out. Oops, there we go. So looking at our first example, our question is, which arrow represents the path of the alpha particle that determined that the atom is mostly empty space? Is it 1 that deflected slightly off the center, the 1 that deflected and returned back to where it originated from, or 1 that went straight through? So I want you to pause the video right now and take about 30 seconds to pick your answer, and then I'm going to review it. And make sure you pause it. The only way you learn is if you try it yourself. Don't wait for me to give you the answer. The answer to the question of which arrow represents the path of the alpha particle that determined the atom is mostly empty space is C, the 1 that went straight through. Because if it was not empty space and it hit something, it would not be able to go right through. It would go off at some angle. Our next question that we're going to look at is, which part of the atom has the most mass, the electron cloud or the nucleus? Give evidence to support your answer. So I want you to take about 1 to 2 minutes after you pause the video and answer this question on your handout. And then when you have an answer, hit play and we can review it together. So make sure you hit pause and try it. Okay, so which part of the atom has the most mass? Is it the electron cloud or is it the nucleus? Give evidence to support your answer. So the answer is the nucleus. Your evidence that you could have used to support your answer is one, you could have talked about the gold foil experiment. So I'm just going to abbreviate that GFE, gold foil experiment, that most alpha particles went straight through. But the ones that hit the nucleus was a very small amount. You also could have used this model of the atom as evidence to show that the nucleus is where the mass is. If we know that electrons don't have mass, but protons and neutrons do, that means that this atom has a mass of whatever's in the center. So if you count it up, that's a mass of 12. So that's another type of evidence you could have given to support your answer. Okay. Oh, no. There we go. So overall, the gold foil experiment told us a lot about the atom that we see today. So one, it's mostly empty space, which told us that the electrons that surround the nucleus have almost no mass. So they take up the most space, but they have no mass. The second thing we found is that we have a dense nucleus, and that's because it holds our protons and neutrons, which have a mass of 1. And then the last thing that we found through the gold foil experiment was that our nucleus was positively charged. So even though the nucleus has protons and neutrons, it is overall positive because the protons are positive and the neutrons are 0. It's not negative because the negative electrons on the atom are surrounding the nucleus and not in the center. So make sure you have all your notes completed. But that is the model of the atom and how we got to it today.